Hi all, this is Saranya from KET Kalaignar Karnanidhi Institute of Technology, Coimbatore. So today I am going to take the topic feed forward neural network. So the process of receiving an input to produce some kind of output to make some kind of prediction is known as feed forward. So we are giving an input, for that input some kind of output will be produced. That prediction is known as feed forward. Feed forward neural network is the core of many other important neural networks such as convolutional neural network. In the feed forward neural network, there are not any feedback loops or connections in the network. There is simply an input layer, a hidden layer, and an output layer. So this is the diagram given for the feed forward network. Here x1 and x2 are the inputs, and then the integration part of some nodes are represented. Three integral symbols are represented in some nodes that are known as the hidden nodes. And then one is known as the bias. So the inputs given from this network are W11, W12, W21, W22 from node 2, and then W31 and W32. And then from the second layer, the input from W11 and W21 and W31 will be given to the next third layer of the node. There can be multiple hidden layers which depend on what kind of data you are dealing with. The number of hidden layers is known as the depth of the neural network. The number of hidden layers is known as the depth of the neural network. So how many hidden layers are there in the network that are known as the depth, that much depth in the network. The depth neural network, deep neural network can learn from more functions. Input layer first provides the neural network with some data, and the output layer then make predictions on the data which is based on the series of functions. So ReLU function is the most commonly used activation function in the deep neural network. To gain a solid understanding of the feed forward process, let's see this mathematically. The first step, how to calculate the mathematical things in this feed forward network. In this, the first step is the first input is fed to the network, which is represented as matrix x1, x2 and 1, where 1 is the bias value. I already told in the diagram 1 is the bias value, x1 and x2 are the two inputs. So in the first step, the input is fed to the network which is represented as matrix. In the matrix form, we need to give the input of x1 and x2 and 1 bias value. Each input is then multiplied by weight with respect to the first and second model to obtain their probability of being in the positive region in each model. So we will multiply our inputs by a matrix of weight using matrix multiplication. So at first x1, x2 and the bias value 1. So the weights are W11, W12, W21, W22. Then we need to calculate the score. In the second step, once we use the weights and then input bias value to calculate the score, that score will be carried on to the third step. Here what we are doing with the help of that score. After that we will take the sigmoid of our scores. We need to take the sigmoid of our scores and gives us the probability of the point being in the positive region in both models. So the formula to calculate that is 1 by 1 plus e power minus x, the score value into the score value. So that is equal to the probability. The probability is find out to find whether the scores are plotted in the positive region or in the negative region. We multiply the probability which we have obtained from previous step with the second set of weights. Actually we are doing these works, giving the input along with the weights, and then we are calculating the score. After calculating the score, we are finding the sigmoid value for that scores, and then finding the probability. And then next we are going to calculate the same thing for the second set of values with its respective weights. So we multiply, at the fourth step we multiply the probability which we have obtained from the previous step with the second set of weights. We always include a bias of 1 whenever taking a combination of inputs. So again we have calculated the next set of inputs and then weights are given, and as we know, to obtain the probability of the point being in the positive region of this model, we take the sigmoid and thus producing our final output in the feed forward process. So 1 by 1 plus e power minus x square, that is equal to probability. Let's take the neural network which we have previously with the following linear models and the hidden layer which combined to form the non-linear model in the output layer. So we are in the continuation of that, we are taking the previous methods. We are taking the previous methods and then we are just substituting. See here, substituting the values for x1 and x2 bias and then the weights. We are substituting and then we have find out the method. So what we will do, we use the nonlinear model to produce the output that describes the probability of the point being in the positive region. The point was represented by 2. Along with bias, we will represent the input as 2, 2, 1. The first linear model in the hidden layer recall and the equation defined as minus 4x1 minus x2 plus 12. After substituting these values in the equation, we will be getting like this. Which means in the first layer, to obtain the linear combination of the inputs are multiplied by 4 minus 1 and the bias value is multiplied by 12. So once these weights are multiplied, what we will get? Minus 4, minus 1, 12, W12, W22, W32. The inputs taken are 2 to 1. The inputs taken are 2 to 1 and then from the linear equation the values minus 4, minus 1 plus 12 are substituted for W11, W21, W31. Instead of that minus 4, minus 1, 12 was substituted. The weight of the inputs are multiplied by minus 1 by 5, that is 0.5 minus 0.5 comma 1 and the bias is multiplied by 3 to obtain the linear combination of that same point in our second model. Because in the second model, see here, in the second model, minus 1 by 5, minus 1, 3. We have to take these 3 as the 3 things as the weights and then we need to multiply that with the second set. Okay. So again what we are doing, we are taking that minus 1 by 5, minus 1 and then 3. We have substituted in the position of W21 to W2 to W32. Okay. Now we have to do the matrix multiplication with this. We need to take the input 2 to 1 and then we need to multiply with the first set of weights minus 4, minus 1, 12 and then we need to take the input 2 to 1 and we need to multiply with the second set of weights minus 1 by 5, minus 1, 3. After that we will get the probability as 2, 0.6. So altogether we have find out the probability score value. Okay. So next for the score value I need to find the probability. So to obtain the probability of the point in the positive region relate to both the models, we apply sigmoid to both points as 1 by 1 plus e power minus 1 minus x. So in the minus x we need to give it as 1 by x. Okay. So 1 divided by 1 plus e power 1 plus 1 by e power 2, that is 1 score and then in the another side next 1 by 1 plus 1 divided by e power 0.6. It is nothing but the sigmoid function is 1 by 1 divided by 1 plus e power minus x. Instead of minus x we are giving 1 by x. So what is the x value that we have defined? 2 and 0.6 as our scores. For this score I am finding the sigmoid function using the sigmoid formula. So I am substituting 2, 0.6 here in this formula. So I am getting the value 0.88, 0.64. This is my probability value after applying the sigmoid function to the respective scores. I got the 2 probability values. So the second layer contains the weight which dictated the combination of linear models in the first layer to obtain the non-linear model in the second layer. The weights are 1.51 and bias value is 0.5. Now I need to take the probability value that I have got in the previous step 0.88, 0.64 and bias value 1 I have to multiply it with the another set of weights. So I am getting the score as 2.46. Now finally we will take the sigmoid of our final score. So the score I got in the previous thing is 2.46. Now I need to find the sigmoid function to get the probability value. So now 1 divided by 1 plus 1 by e power 2.46. I have applied the sigmoid function for the previous step score that I have obtained. Previous step score that I have obtained is 2.46. Now I am applying that in the sigmoid function to get the final probability value 0.92. So this is the method to calculate the solution in our feed forward neural network. So first set of weights we need to combine it with the weights. First set of input we need to combine it with the first layer of weights, and then we need to obtain the score value. For that score value we need to calculate the sigmoid function. After that, finding the sigmoid function, we need to calculate the probability of it, and then we need to take that particular value and then we need to apply it to the second set of weights. We need to calculate the score. For that particular score we need to find out the sigmoid function to get the probability value. So one set of value we need to combine it with the particular layer weights, and then we need to feed forward the output of the first layer as the input to the second layer. Next, the input to the second layer is got, and then it is combined with the weights of that particular layer, and then again we need to calculate the things, and then we need to find the final score.